Let's think about people for a moment. When you think about IT and why we are actually doing what we're doing, isn't this too loud? What we're doing effectively is because somebody is either using our software or we're writing software that somebody is using for their software that somebody else uses. And for the end users of our product, the rule of thumb is that it's nail till you ship it.
Your customers won't know the difference, whether you're actually doing anything or not. So in this talk, I'd like to tell you a bit about how we ship code. And I find that there's three major things that there are to being able to both move fast and be able to ship code in a stable manner. And that is a stable architecture, continuous delivery, and taking ownership. So I work at Base, and we're a CRM, we're a startup based in Krakow and Chicago. And it might scare you a bit, but Base started as a Rails application. It was a huge monolithic application with built-in authentication. It was effectively rendering everything. So whenever a request came from the user, the whole thing would be both fetched from the database, and the whole HTML would be rendered for the user. It had just one database. Now, when you think of an application like this, there usually comes a point when you need an external API. And usually when your external API is a separate thing from your main product, it effectively serves a really narrow set of features. It sometimes is completely impractical to real-world use. And usually it might be buggy or poorly maintained, but because your developers don't use it. So what we do and what we set out to do at the very beginning is dogfooding our APIs. So at some point we made a conscious decision to make all of our front ends and all of our features use the public APIs. What this effectively made was making every single front end become a client of our API. Now, when you dogfood your APIs, you guarantee that your APIs are complete, that they're well tested because they basically run your whole product, and they allow third-party integrations to be extremely easy because all the features, all the business logic that they would potentially need will already be in the API. We chose Backbone.js. I'm not sure if you guys are familiar. Backbone.js is an MVC, JavaScript MVC framework for building rich applications. And its main features are the event-driven communication. So up until a certain moment, you might be able to build your front end based on jQuery, but at some point, when the application becomes too large, you effectively need to be able to relate to your views and trigger actions based on events. What Backbone.js also serves you is the ability to sync every single model and every single collection via the API. When you dogfood your APIs will already be there, so it's extremely easy to simply plug that in. What Backbone.js also offers you is great modularity. You can split your application into, well, a lot of modules, but also be able to reuse them in different parts of your system. And there are a few approaches for building applications based on JavaScript, like client-side JavaScript MVC frameworks. And the first two that come to mind is having one massive front end. So effectively having all your application in a single code base. But as your application grows, your user will have to load more and more code into his browser. Sometimes they might not actually need it. So what you might do is create separate front ends for separate parts of your system. This obviously has a few downsides. So whenever you switch to a different part of your system, whenever somebody clicks or navigates somewhere else, he'll get the page. If the page reloaded, the code has to be updated again. What we decided to do is build a top-level front-end application, top-level Backbone.js application that dynamically loads every single module that the user might need. So if you navigate to the reports section, the routing in the top-level application will detect that you actually need the reports module. It will load this module and don't load it again up until you leave Base at all. So whenever you switch to navigate to a different part of the system, it dynamically loads whatever you need and effectively makes the application seem way, way faster and be way, way faster. So in our system, as we exposed to other APIs and we wanted to expand our product base, we decided that our authentication system needs to be universal. And the authentication system within the main product was simply starting to overload it. It was handling a lot of requests that were unnecessary to be there. And it effectively became our first service. We extracted the authentication system into a separate application. And this was the first step in going towards a service-oriented architecture. So SOA is effectively an architecture that allows you to isolate your services, isolate their storages. It allows you for designing your system for failure. So whenever one part of your system breaks down, all the other parts will actually work. Whenever one of the storages breaks down, you get to actually work on the rest of the system. Your modules become completely reusable. So say you have a tagging system, you can have one tagging service, and whenever you need to update it or you have performance improvements for this specific part of the system, you might reuse it in different in different services. And what SOA also offers us is being fully agnostic. So we don't need to be limited to one language, one architecture, or a specific framework. So service-oriented architecture comes with a huge cost at the very beginning. When you have a application set in place, you will have to extract some parts of the system towards separate services. When you want to build quickly prototype an application or create something from scratch, it usually will make you do quite a lot of over-engineering at the very beginning. But we decided to go for SOA, and this meant extracting a lot of services, a lot of testing, and separating storage into different databases, which was extremely costly. And whenever you want to perform such an action without any downtime, it becomes quite problematic. So when you go for SOA, one of the most important parts is unification and simplifying the way you call different services. So we create a library, and this library allows us to, it basically has all the routing and all the serialization built in. It allows us to call every single API in our system from within, for instance, the Ruby code. So we might want to find the account, right, or perform actions within the user context. So effectively use all the authentication that the endpoint service offers for limiting the resources. Now, I said about staying agnostic because this is what SOA offers us. And in order to stay agnostic, you need to define a way of communication that will be, easily for different technologies, different frameworks and languages to plug in. We decided on a fully API-based communication, so there are no different calls to the system. Every single service exposes an API that uses JSON for both posting information as well as retrieving. And it's a great idea to actually unify your responses, your JSON responses from the very beginning, so that every single response looks pretty much the same. We came up with a format of our own, so effectively whenever you ask for resources for this, for instance, this is a list of zip codes for some kind of user. What you get by this is every single JSON response in your whole system can be serialized in the same way. So you know exactly where to look for the items retrieved, where to look for the additional metadata like whether the service that you asked or a depending service was actually up, or for instance, the total count of objects. What we also decided on is using absolutely no XML in our system, because we all hate XML. I hope that nobody here is offended. Cool. But what did SOA give us? SOA gave us faster development. And as I said at the very beginning, SOA put a lot of overhead at the very beginning. But right now, our whole application is split into smaller modules. So specific teams, specific people can own their own parts of the system, effectively knowing a lot about them and being able to move faster within the scope of the service. Now, I'm gonna say about us having less bugs, but effectively, probably the number of the bugs is the same whether you use SOA or not. But being able to react and basically nail those bugs down is way easier when you go for SOA. When you have a single module and you can nail down the bug to be actually there, you get to work on it way faster. You know who will be responsible, and effectively shipping this single part of the service with the fix will be easier. So this brings it down to also an ease of maintenance. So I think I said this at the beginning. Every single team owns parts of the product. They know how to maintain it, what are the issues in terms of performance, and so on. When designing, when you deciding for going SOA, one of the important things is deciding on a specific framework. And the frameworks that we used were custom-based. They were actually Ruby. They are actually Ruby, most of it. And they have customizable interfaces. And at some point, when you actually think about HTTP requests, there are moments when the HTTP protocol itself can actually slow you down. And this is when you might actually want to, for instance, create a TCP connection or actually go to having your interface exposed to a queuing system for speed. What we also used was customizable serialization. And this also allows us to maintain, in terms of performance, depending on how much data the user actually needs, you being able to serialize it in a customized way. And being able to select attributes and related services data for your responses can improve the performance greatly. So over the last 2 years, we've experienced quite a lot of growth. And right now, from those 2 services, we expanded to over 30 services right now. And they're all on over 100 AWS instances. And by going SOA, we managed, so these are the stats for our authentication system. At the very beginning, we had around 360,000 calls per month, and this grew to 150 million just last month. And the average response time was brought down from 46 milliseconds down to 23 milliseconds for authentication and token and session-based authentication. And right now, the whole system runs around 1.5, 1.4 requests per minute. This is like data for the 7 most important services, and it amounts to about 60 million requests monthly per service. But when you get to a lot of growth, and again, when you get to having a lot of requests and a lot of dependencies in the system, at some point you need to figure out what's actually going on. So say you have a situation when you effectively remove one of the users from the user service. You remove the whole account and you need to do something about their data. Now their data is stored in different services, and what you can do is make synchronous calls, maybe live or a background job processor, which effectively calls every single service and tells them that, oh, hey, this account was removed, so do whatever you have to do. But this is not scalable. With 30 services, whenever you remove a user, you would have to make 30 requests. And actually, the service removing the user would actually have to know about the existence of different services that might need this information. So what you use for this are message queues. And we use a message queues. What this allows you is push an information, an event, to the message broker. The message broker then sends it out to different queues. And every single service can sign up to listen to specific events on those queues and do whatever they want. They might go ahead and ignore the message, or they might actually handle it the way they were built to. And we decided for using RABBITMQ, and RABBITMQ as, it's extremely performant for us. We had quite a lot of issues with it, but yeah, RABBITMQ allows us to subscribe to specific messages, and we built our own workers that are running on an event. It's called Event Machines, a Ruby library for event processing. And effectively, what you do is you create a dispatcher that will fetch the events, work on events, and fetch specific events, and you can sign up specific handlers for specific messages that you receive. So whenever you don't sign up to any one of those, it will actually be skipped. Actually, it will be acknowledged. And when you actually have to do anything about this message, you define a handler. you define a handler that will do whatever it has to do. And now RABBITMQ, which we introduced about a year ago, is now handling over 10 million, almost 10 million requests monthly. And I think that if we didn't decide on using a message queuing system, we would be in a pretty bad situation. Okay, so like I spoke about the architecture and Rabbit and communication and so on, but there's one important thing that's testing. When you test a service-oriented architecture application, you need all your services to be fully tested, and preferably you should use continuous integration when you have a lot of teams working on different parts of the system. Now, there are two approaches that we found out along the way for actually being able to test the whole system. Now, what you can do in your test environment is mirroring your whole production. So effectively in your continuous integration suite, you would have a copy of your production environment that would basically perform every single request. Now, it's extremely hard to maintain, but also it's extremely slow. When you have to make every single request, say you create a tag for a contact, the testing environment actually has to make the request. If the network's slow, whatever, you get to experience that slowness. So what you can do is test every single service in isolation. When you test in isolation, this is what we decided on doing. What you need to introduce is API versioning. So whenever you decide on an API version, on an API structure, you need to version it and not change it in the future. What you should do when what we do when we test services, we mock every single external call internally. So whenever we set out that we decide that the API response should look the way it should look, it's being tested somewhere else. We don't change it, it's tested somewhere else, and we just mock it, either using, some Ruby libraries, never mind. Effectively, we write those tests, we mock those responses ourselves. And the main thing is here is to preserve the API responses so that they don't change in the future. And when you test in isolation, you should actually be testing the whole request. So it shouldn't be just unit tests inside there, but you should be testing the whole broker, the whole controller that will then both parse the parameters, perform all the actions, and you need to validate that the response is actually valid. So you should be probably testing for presence of specific attributes so that if somebody wants to remove this in the future, they should be informed about the fact that they broke something. You should also be simulating every single erroneous response. So we test in isolation, and you might think that this is not really enough. So there might be parts of the system, the integration tests that we are missing, and that is definitely true. We also do happy path testing in Selenium. So we have tests that validate the core functions of our system. So if this happens, and obviously sometimes does, that somebody, our test suite didn't cover something, we have tests that will preserve the validity, the correctness of our system. So effectively, like creating context, setting tags, or creating the most important business logic operations are being tested with Selenium, and this is probably like some sort of a fallback for us that we need in place. But when it comes to testing, I think that there is actually nothing better than an amazing QA team. And effectively, without those guys, all of our testing and all of our ideas we wouldn't be where we are right now. Okay, so I told you a bit about architecture, but I wanted to also tell you about continuous delivery. Now, when it comes to delivery and being able to release all the time, the rule of thumb is when you're stable, you get to release all the time. And there are three most important parts of being stable and being able to continuously deliver. And this is automation, automation, and automation. What you should be automating is setup, testing, but also delivery. When I talk about setup automation, is whenever somebody wants to start working on a service or whenever somebody joins the team, usually they have to set the whole environment up on their machine. And this can sometimes take a lot of time when you want to create an environment consisting of 30 separate services, it becomes a few days of work to actually get the person running. And you don't want this. So we created a Stag application. It's called Stag. It effectively fetches the code for the user. It runs all the bootstrap, all the configurations. It will run the specs for you, the local database migrations. It will create the database for you. And effectively what you have to do is type in stack install sales frontend or stack install sales, and it will set everything up for you so you get to code immediately. And this is pretty much is becoming a relic for us. It's also not becoming scalable to create a Stag application for every single file, every single service. So what we decided on doing was creating a Vagrant plus Puppet environment. Puppet is a configuration management tool, and Vagrant gets to create a virtual machine that you can have running on your own system and effectively have all the code running there. For instance, an Ubuntu virtual machine that has everything set in place. And this is effectively the next step for us. We're already working on this. All right, so when you're testing everything and you want to be able to make people sure that they get to deploy software, your master branch should always have passing tests. And whenever somebody breaks a build, you should get instant notifications. And probably this might be a standard for some of you, but sometimes it is not. So whenever somebody breaks the build, we get an information. We get to know who might theoretically be responsible. The person responsible will also know, and effectively we can start hacking on this and fixing the issue. So what this gives us is that the master branch on every separate service is always deployable, unless obviously the test is broken. But whenever the test passes, we know that anybody who wants to make a hotfix or perform a change in the system can do it whenever they want. For bigger deployments, we have a SANDBOX environment in place. And SANDBOX is an environment that is supposed to mirror the production environment. It's set up somewhere on a different domain. And whenever a larger feature is supposed to be shipped, we will do pre-release testing there. It's supposed to be a copy of the production environment, but what we're missing and what I encourage you to do whenever you would like to set an environment like this up is have a production scaled copy of your data. So obviously this shouldn't be a copy, it should be all faked. But effectively there are parts of the system like migrations, so your the way Rabbit handles messages and the way services handle load, that will be completely different on your SANDBOX environment than from your production environment, which could and did end up in quite a few surprises when you push to production. So we have our branches tested. We have them always deployable, but what we want to do with every single deployment is make every single deployment be a cautious operation. So we don't just go and yeah, let's ship, I'm drunk and I don't really care. Everything should be cautious. Every single deployment should be fully automated, and they also should effectively become an ordinary operation. So this should be something that you just do, and this is not something that you need somebody's permission or a week of preparation for. And in order to automate our infrastructure and our deployments, we created a tool that's called Grid. And Grid allows us to, this is basically, it allows us to deploy stuff dynamically. Grid, it's operating, I'm going to talk about this in a moment, it's operating on an MIT star cluster. And it's, the whole library allows you to predefine resources for your service, but also allows you to dynamically allocate workers within your infrastructure. And those predefined resources might be web workers, so workers that actually handle your HTTP requests, background job workers, but also RabbitMQ workers, the ones that listen to the events and fetch stuff. You can predefine your resources within Tag just by going in there and finding the service. You can find it by name, but also by environment. So SANDBOX or production. You can define the number of web workers, background workers. I should have tags.save here. But effectively, every single tool will automatically fetch data from this database and see how many workers should be present. If you expand this number or you limit it to a lower number, it will dynamically either create new workers or kill them. And I told you about dynamic allocation. So we use a star cluster. Every single grid instance is a whole machine that also has a few nodes related to it. And we have multiple slots for web workers, background job processors, and RABBITMQ workers that we allocate dynamically. So this is what, yeah, it's this amazing graph, I know, but effectively, whenever you deploy, and the deployment knows that you need 8 web workers, it will go through the cluster and locate 8 slots for your application. It will make sure that not all of the workers are on the same machine, because effectively when one of the machines goes down, you go down, and we don't want this. It will find and locate dynamically the slots for your application, and then one by one, it will insert the code there. We'll run all the migrations, install all the gems, configure it, run the background job processors, Rabbit workers, and then at the very end, detach routing from one of the old workers and attach the new one. So dynamic allocation allows us for almost endless horizontal scaling. Whenever there's a lot of growth and maybe we have performance issues that we haven't noticed before we get to fix them in order to preserve a fast system for our users, we get to add more workers and deal with it along the way. So effectively, whenever somebody wants to deploy a service, they just type in grid deploy task production, and everything happens automatically. When you deploy with grid, grid also makes sure that you restart whatever's necessary. So it will not run database migrations unless you actually specified some migrations in your latest commit changes. It will perform a health check, so see whether the service that you actually deployed is running before attaching it to routing. And then it attaches routing. So everything is being handled automatically. A deploy might take like 2 minutes on sometimes like 10, obviously for bigger services. But it's effectively a quick operation that you know is going to succeed. What this also allows us, grid, there's a handy little thing that allows us to go into specific service, grid console task production. It will, you can also specify which of the available instance you want to get onto. So immediately, whenever something's happening, you might be able to log into the machine itself and see what's going on. One of the two main things that we're working on, but also having partly in place, is resource isolation. So we want to implement being able to isolate specific services in Linux C groups, which would allow us to limit CPU, memory, and disk usage for a specific service within the cluster without affecting the other ones. But it also allows us to internally blacklist services that are underperforming for some different reasons, for instance, some database failure or something like this. And so I said about those two things, architecture, delivery, and I would like to say a few words about ownership. I think the human factor in this whole process might be actually one of the most important. So we take ownership. Everybody owns a part of the product. Everybody is responsible for bits that they created, and we want to preserve it that way. So everybody can commit to master on every single service. We all make sure that we deploy, whatever we deploy is sure, and everybody can deploy at whatever time they want to. So one thing that we want to do is whenever somebody joins, we always make them deploy on their first week. And this happens due to the deployment being automated, the setup being automated, and effectively it allows those people to have immediate influence on the product, and it familiarizes people with the whole process and relieves them of anxiety whenever they would like to ship a feature on a different time. So we take pride in coding, we take pride in shipping and influencing our customers. And what this allows us is to deploy 20 to 40 times every single day. And I think this is quite a feat. So to sum up, in order to ship often, you need to be stable. And whenever you get to ship often, you will be able to move fast. And this is effectively what affects our customers. Thanks. Any questions?
Okay. Thank you very much for the great talk. Are there any questions? Well, since I'm in charge, I will have the first question. Where's actually the Python part here?
I think, so I used to code a lot in Python back in my early days. But I think this is something that I wanted to tell you. This is something that for me 2 years ago would be completely unimaginable. Having that much services, having an infrastructure that huge. And it effectively was built on top of a dynamic language, which usually is not used for this kind of stuff. Ruby and Rails are used for usually for single like worker applications or prototyping, and we managed to build something quite amazing. And this is something that I would like to share with you guys, because a lot of these things that we encountered along the way were completely unknown to us. Yeah, I hope that worked.
Yeah. Okay. Thank you for the presentation. It's really great, and it really gives great ideas for new stuff. Anyways, I was wondering, with versioning of APIs of different modules, do you run into version hell, dependency hell? Basically, when you, for example, you have two modules that depend on a tiered module, but they require different version of the versions of this tiered module and stuff like that. Do you have any tips on how to avoid that?
So one thing that we encountered lately was that making separate calls depend on, like, having calls of a greater depth than one are effectively will slow your system down. So whenever you, for instance, let's say you have a contact that you would like to get from the system. So when you get the contact, but you also ask for tags for this contact, you should avoid making the reliant service ask for the next service, right? So if you need contacts and its tags, you shouldn't make a shortcut through this module. I don't think this API should then like require the next one. You should actually be the one making two calls and joining all the data together. When it comes to versioning data and testing this, what we do is this game that I showed you, this FS API CRM account, you get to specify the API version that you need. So if you need like specifically the version 2 of the API when there's 4 available, you can specify this in the call. So then when you actually test and you mock this request, you will know that you are actually mocking the request with V2. If somebody changes this in the code along the way, they will know that they just changed the version of the API because the test will fail. Yeah, and then it's their responsibility. So either they upgrade the requirement to the new version of the API, or they just leave it and try something else. But effectively, this should be tested. Yeah.
I have actually 2 questions.
Yeah. Don't see you. Okay. Cool.
Do you, like, when you push it to the clients, do you have like goes on?
So this is something. All right. So most of our product is available through front ends from the backbone applications. So recently, for instance, we released a new filtering and sorting mechanism that uses Elasticsearch extensively. I'm not sure whether you guys are familiar or not. It's an indexing system, like distributed Apache Lucene thing. And the thing is, we weren't sure whether it's going to perform well for every single client. So what we then did was, we have a multi-tenant application. So our application, everybody has their own like part of the data. What we did was, in the code of the application, the top level application, we created a flag whether to use the new filtering and sorting or not. And then we wanted 10%, so we effectively created a account ID modulo 10. If it equals 0, then you get to use the new feature. If not, then you don't. So by having the front end exposed for all of our features to the users, this is how we managed to achieve like deploying to just 10% of people.
Yeah, but my standard feature of yours that when you push it, it gets like 5%, and then the next question was a follow-up. What happens if it fails? So do you have like automatic failure?
Yeah, so this grid, the thing that I told you about, this has the health check. So if you push something and it's completely broken and it doesn't like run, it will not it will not go further. So unless it gets a proper response for the first service that you deployed, it's not going to move forward and probably let you know that the deployment is stuck. And it's not going to attach routing to this service. Yeah.
Hi, great talk.
Hi.
You said that you do close to 40 deployments per day. It's one deployment every 20 minutes or so. Do you coordinate them somehow, or do you do them concurrently?
That depends on the length of the day, that's for sure. But we basically have like the team structure at base is that we have specific teams that handle different parts of the system. So for instance, there might be a team that handles the email integration, or a team that handles voice integration. And effectively, this specific team, it's like a small startup within the whole startup. And they coordinate, like every single team coordinates their own deployments themselves. But there are also people responsible for actually pushing stuff, and as well as every single team has their own QA, like quality assurance person that tells them whether this should be shipped to production or not. Yeah.
Okay. I have two questions. First off, you said that you have like 40 deployments a day. That means you deploy like every 20 minutes. How does that work with Selenium? Do you manage to actually run it before deploying, because we use it and it's
slow.
Very, very slow?
Yeah, okay.
And I have a second question. You say all this nice stuff about your process and stuff. How long did it took to develop this process?
Mm-hmm. So I'm going to answer the first one. Because we know Selenium is slow. So effectively, we don't run Selenium tests before deploy. Selenium is, we depend on our main tests, mainly, right? But we also have, so we have the sandbox environment. So we can have Selenium tests running both there and on production. And usually the process goes, like people that want to ship will go through sandbox before going to production, unless they're like perfectly sure or it's a super quick hotfix. So those Selenium tests could fetch any broken stuff on sandbox before it actually gets shipped to production, like really early on. But to be honest, we don't wait for Selenium tests to go green before we push to production. Usually we expect our own testing infrastructure to be enough. So if something is actually broken on production automatic tests, I'm saying automatic because it's called automatics, never mind, but Selenium tests, well, we will know after it's been deployed, but we haven't had a situation like this yet. So this might be a good thing or a bad thing. Either the Selenium test doesn't work or we never had a problem. And to respond to your second question, which was, can you please remind me? Oh, well, we've started like almost 3 years ago. So effectively, I'd say that the service-oriented architecture was a decision that we took almost 2 years ago. And we were slowly going through this. Grid is effectively a tool that was built around a year ago, and it obviously got developed along the way. And when it comes to Backbone.js, the whole rewrite of the system towards Backbone.js, we previously used like our own JS framework, but we didn't really manage to maintain it properly. And the whole Backbone.js thing happened around one and a half year ago.
I have 3 questions.
Cool.
I don't know if there is a limit. One is, you said that if the deployment fails because, for example, the application doesn't even start.
Mm-hmm.
But what if it starts and there is a bug discovered? Do you roll back somehow or work on a quick fix? What is...
Okay, so the rollback feature is something that we have in planned in the roadmap, but it hasn't been developed yet. But it will effectively be the part of the grid thing. So whenever you break something and it's like renders the whole system completely unusable, we obviously haven't had a situation like this yet, but I hope we never do. Effectively, this should be the part of the grid application. So when you type in grid deploy tax production and you broke something, you should be able to type in grid rollback tax production, and it will bring you back to the previous version. But usually we immediately work on a fix. Yeah.
And your application is a multi-tenant application. On what level do you isolate resources and the data in your application?
The whole design was not really expecting the scale that we managed to achieve over time. So every single every single service has its own database, but we don't shard. We thought about sharding the databases, but we aren't really at a place yet that actually forces us to do this yet. But this is something that we're strictly considering, to be able to shard specific accounts data into specific parts of, or specific instances of the database. What we did though was, when you use Elasticsearch, and we're like currently indexing all of our system data within Elasticsearch, we used custom routing there. So effectively, this allows you to, I'm not sure how familiar you are with Elasticsearch, but Elasticsearch has multiple shards for the whole instance. And in, basically, a shard is a Lucene, Apache Lucene instance. And being able to custom, like when you insert a document into Elasticsearch, like usually it gets its own hash, like from a hashing mechanism from Elasticsearch. So for the future, when you need this one particular document, it knows where to look for it. But when you perform a search or a huge filter on all of the data, it will then ask all the shards. So what we did, we implemented custom routing, and custom routing allows us to specify on which shards those account data should be. And this allows us to improve performance of Elasticsearch greatly. And we use it in a lot of places right now, especially for some funky sorting and or filtering, because the size of the database made us, like the size of the database, for instance, for the context, so one of the main features, is large enough when we use MySQL that we cannot really handle joins anymore. Whenever we perform a join on this table, the MySQL server will effectively die. So we switched to Elasticsearch, yeah, decreasing the load on the MySQL. But we use sharding there, and this might be a good solution for the future for MySQL.
And the last question, when you deploy to your grid, it might be distributed on many nodes. And do you have any mechanism to track, for example, user requests? So where it comes in and it fails somewhere, you know where it was.
Yeah, so we use for monitoring, we use New Relic. And New Relic, when it retrieves the data, an errorless data or a very slow timeout, like very slow request, it will also assign the number of the node that where it happened. So we get to be able to track this. And also, like we use Honeybadger. I'm not sure if you guys know Honeybadger for error reporting. It effectively also attaches the name of the node that the situation happened. But before something like this happens, we use the blacklisting. So if there's a node that was failing, for instance, because its database failed, or I don't know, its connections were limited, and it starts timing out like a madman, it will get internally blacklisted, and we get to be notified that this node, this instance on this node was blacklisted because it was underperforming. So it doesn't affect the end user.
Is this working? Okay. We already know it took. Okay, we know it took 3 years to build the system.
Mm-hmm.
How many people worked on it to get the full picture of the resources involved?
How many
people worked on getting the system to this point?
Mm-hmm. So, well, how should I present this data? So along the way, well, we started effectively when we were extracting the services for the first time. There were 3 Ruby coders when it comes to backend. So right now we're about 60 people here in Krakow, and a marketing team and sales team in Chicago. But over the time when we started separating SOA, it was around 5 people, 6 people. And then the Backbone.js rewrite was done by, I think, well, it was done, actually Backbone was like a really cool sprint that we did in 4 people over like 7 weeks, that we rewrote the whole system in Backbone.js. Yeah, that's pretty much it. I mean, unless you want to know like some bits of it, because Grid was built by mostly our DevOps team, but also by our CDO, who was also before this one of the Ruby coders.
I was just wondering, because just the time is not really a good representation of the resources involved into making such a system.
Yeah, so I'd say like last year in October, we were about 22 people. And up until then, we had the SOA in place, as well as Backbone.js, as well as the Grid was already there. It wasn't as developed as it is right now, but it was 20 people, the whole team.
Okay, thanks.
Hi.
I would like to ask you, how do you deploy and manage configuration?
How we do what?
How do you deploy and manage configuration?
On many configurations?
Manage configuration.
With or without?
No, how do you deploy and manage configuration?
So right now we mostly use Puppet for configuration management. This is why we also, for the future, we want to use Puppet in the local development in order to fully reproduce the production environment within the local user's environment. Yeah, but we use Puppet, and it's extremely performing extremely well for us. And we use Puppet also to both set up machines, but also Elasticsearch is being configured directly from Puppet. So, yeah. Right.
Okay, I have one question.
Sure.
I read somewhere that your main competitor is Salesforce.
Salesforce, yeah.
Yeah. I have a question. Do you have also a app store, something like that? Because you can actually, yeah, the app store is the one question. The other thing is, just client can simply deploy their own code in platform?
In our platform, no.
Yeah.
But they can. We have a lot of integrations that like external companies did, and they managed to integrate with our APIs like seamlessly. So I'm not sure. There's this like web events triggering startup called Zapier. I'm not sure if you guys know, but they let us know that they integrated with us like I think 5 months after they actually like announced that they have an integration with us. So we didn't even contact them. But we don't allow people to like deploy code in our code base, but they get to they get to integrate really nicely.
Any other questions? Okay, thank you very much.
Thanks.